Hey everybody, Mr. Judson here. So we are done learning. Our Central Washington final is going to be on June 9th. And so we've got this week and a couple days next week to review. So I think what I'll do is I'll start at the end of things and move back to the beginning. That way the things that are farthest back, that are probably not quite in our minds, we'll get that closest to the test as possible. And so what I'll do is, I'll just, kind of like in class, I'll write down a problem, you guys go ahead and try it. Then I'll give you a couple seconds, you'll pause the video of course, and then I'll work it out and move on to the next one. Yeah, so nothing new. Alright, so we'll start with this one. We began chapter 8 with basic integration. And so what I have is the integral from 3/2 to 2 of 2x times the square root of 2x minus 3 dx. You guys go ahead and give that a shot. Alright, so I would look at this and probably think something inside parentheses raised to an exponent. That always makes me think substitution. This is not the derivative of that, but I could always do the change of variable technique. So I'm going to let u equal 2x minus 3. Therefore, du is going to equal 2, and I just took the derivative of x. So I'm going to have an integral, and let's see, when x equals 3/2, if I plug that in, 2 times 3/2, that would be 6/2, which is 3, minus 3, that's 0. And if I plug a 2 in, I get 4 minus 3, that's 1. See, this way I don't have to plug the 2x minus 3 back in. We'll just convert everything over to u values. Alright, so right here I've got u to the 1/2. My 2 dx is going to be du. The only thing that's left is what am I going to put in place of that x value? And so I'm going to have to solve this for x. So I've got u plus 3 equals 2x, and then that means x equals u plus 3 over 2. So that's what's going in right here. U plus 3 over 2. And so I'll go ahead and move that 2 to the outside. So I've got 1/2 times the integral from 0 to 1. I'll distribute this u to the 1/2 to the numerator here, so I get u to the 3/2 plus 3u to the 1/2 du. And now we can just go ahead and add 1 to the exponent and divide by the new one. So u to the 5/2 divided by 5/2, which means I'll multiply by the reciprocal, plus 3u to the 3/2 divided by 3/2, and we're going to evaluate that from 0 to 1 and then multiply by 1/2. Alright, so I can see that the 3's cancel, so let's just go ahead and do that. Alright, so now I'll evaluate this from 0 to 1. So if I plug in a 1, I get 2/5. Plug in a 1 here, I get 1 times 2, that's 2. Minus what I get when I plug a 0 in, I'll get 0 here, 0 there, and multiply that whole thing by 1/2. So if I convert this to fifths, that would be 10/5 plus 2/5, that would be 12/5. And then divide, or times 1/2 still. And so what I get is 12/10, which simplifies down to 6/5, which is about 1.2. Well, not about, it's exactly 1.2. Alright, so now I want to check this on my graphing calculator. And so, we've done this before. To do this, I first of all want to graph this equation. Okay, so I'm going to go to the y equals, so you guys should do this along with me. I'm going to type in 2x times the square root of 2x minus 3. And for a window, I only need to see from 1.5 to 2. So I'll go from 0 to 3. Y values, we'll just try, I think everything here is positive, so I'll try 0 to 8. I hit graph, and there's what my graph looks like. I just got this curve, it's right here. And so to do a numeric integral, okay, this calculator can go from here straight to the answer. It just can't show us all the work in between. You know, that's why you got to have work to get credit on this test. But it'll at least tell us the answer so we can check and see if we did things right. So I'm going to go second calc. That's where you find your zeros and your maximums and minimums. What I'm going to do is option 7, which is the integral, means the area underneath the curve, and I'm expecting that for an answer. So my lower limit, that's 3/2, 3 divided by 2. My upper limit is 2. And there it is, I get 1.2000202. So I got a little extra on this one. But the thing we want to remember about the T84 is it goes through this process until it thinks it got close to the right answer. And so it thinks it's close, but it didn't quite get close enough. If I run this off to 3 digits, I'm going to have 1.2. So there we've got the same thing. All right, let's try another one. All right, so remember, the one thing that I told you guys about Central Washington is they'll tell us what process to use, and I told you they like Chapter 8. Okay, so that there'll be a few problems from Chapter 8. But the nice thing is they don't just give us an integral and then we've got to figure out, okay, is this partial fractions? Is it integration by parts? Trig substitution? You know, what is it? They'll tell us, which is a big deal. I mean, that drops the level of difficulty of this test by quite a bit. Okay, so we want to solve this one using integration by parts. You guys go ahead and try it. All right, so I see something that I can take the derivative of, and it does get simpler. Derivative of this would be 2x, and the derivative again would be 2. And I could integrate this, and it doesn't change. Remember, anytime you see e to the x or sines or cosines, that's usually a good time to use the tabular method. So I've got the sine, I've got my u value, I've got my dv. Go plus, minus. U is something that's easy to, and it gets simpler. So that would be 2x, and then 2, and then 0. Remember, you can write this kind of stuff down on your note card, or your note sheet. It's an 8.5 by 11 piece of paper. You can say u needs to be something that's easy to take the derivative of, and it gets simpler. You can remind yourself of that. dv is something that you can take the integral of. So e to the x, integrate that, you get e to the x, e to the x, e to the x. And then from there, it's just, we don't want the first one. We go across and then drop down 1. Go across, drop down 1. Go across, drop down 1. And the next one's going to be 0, so we don't care after that. All right, so my answer to this integral is x squared minus 1 times e to the x minus 2x times e to the x plus 2e to the x plus c. Don't forget the c value. A lot of times I get asked, it says you have to show your work to get credit. Is this considered showing work? Yeah, that's my work right there. So yeah, that works. All right, let's try another one. This one, we're just solving the trig integral. We're not using trig substitution or by parts or anything like that. It's just a trig integral. You guys go ahead and try it. All right, so the derivative of a tangent this is secant to the 4th, by the way, sorry. Tangent theta times secant to the 4th of theta d theta. So the derivative of a tangent is a secant squared. So what I want to do is factor out a secant squared and convert the rest back over to tangents. Or I could factor out a tangent and a secant and just go with that. Then I don't have to convert anything. So that might be a better route to go. You can go either way on this problem. So I think what I'm going to do is I'm going to call this the integral of secant to the third of theta times secant theta tangent theta d theta. And if I let u equal a secant theta, then du is a secant theta tangent theta times the derivative of the angle, which is 1, and I just took the derivative of theta. So you got to see that whole thing right here. And so this is really just the integral of u cubed du, which my answer is u to the fourth over 4 plus c, which means I've got secant to the fourth of theta over 4 plus c. And if you write that as 1/4 secant to the fourth, same thing. All right, there it is. Let's try another one. All right, so this time we're going to use trig substitution. Got the integral of the square root of x squared minus 9 all over x dx. You guys go ahead and try it. All right, so when I look at this, x squared minus some number, that kind of looks like secant. Secant always starts with your x values first. And so what I want to do is I want to do u equals a secant theta, which means x is equal to 3 secant theta. And if I take the derivative of that, dx is going to be equal to 3 times the derivative of secant, which is a secant theta tangent theta, times the derivative of the angle, which is 1, and I just took the derivative of theta. So if I substitute everything in here, I'm going to put 3 secant theta right here and square it. So I've got the square root of 9 secant squared theta minus 9 over x, which is 3 secant theta, times dx is going to equal 3 times secant theta tangent theta d theta. And now we just got to simplify all this stuff. So to do that, this 3 cancels with that 3, that secant cancels with that secant. And let's see, this thing right here, if I factor a 9 out of each of those, I get the square root of 9 times secant squared theta minus 1. And that's equal to a tangent squared of theta. So square root of 9 tangent squared theta. And so the square root of that would just be 3 tangent theta. So what I have now is the integral of 3 tangent theta times another tangent theta d theta. And so that'll give me, we'll move that 3 to the outside. Here I get tangent squared theta d theta. And I don't know how to integrate that. That's not one of my formulas. But I could go back and think tan squared plus 1 equals secant squared. So let's just change that tangent squared back to a secant squared minus 1. Because that is one of my formulas. So my answer here is going to be, see, if I take the derivative of tangent, I get secant squared. So the integral of a secant squared is a tangent, theta. Here I just get theta. Got to multiply that whole thing by 3, and then plus c. That plus c probably should be in here, but when you multiply it by 3, you just get some other constant anyway. All right, so I still have to convert everything back to x's, which means I need a picture here that I can work with. So let's see, this right here means that a secant theta equals x over 3. which means a cosine theta equals 3 over x. And so if I set up a triangle, here's theta, cosine is adjacent over hypotenuse. That means this side over here has to be the square root of this squared minus this squared. Which again, it should look the same as our square root that's over here. Alright, so now I could say that a tangent is opposite over adjacent. So I've got this 3 times root x squared minus 9 over 3 minus 3 times theta. And if I'm solving for theta, right here I would say theta is the arc secant of x over 3. Or you could say the arc cosine of 3 over x. Either one of those. I think our book always went with whatever you had first here. So I'll say arc secant of x over 3 plus c. There it is. Alright, so let's see if we can solve this one using partial fractions. So I think I'm just going to move that 3 to the outside, call it 1/3. And so what I want to do is I want to say that 4x minus 2 over x minus 1 squared is equal to a over x minus 1 plus b over x minus 1 squared. And so then if I multiply through by the common denominator, this will cancel, so I get 4x minus 2 is equal to, I'll have an x minus 1 squared here, so one of those will cancel with this. I'll still have an x minus 1. And then when I multiply here, the x minus 1 squares will cancel, so I'm just left with b. Alright, so let's let x equal something that makes this equal 0, so that'd be 1. If I plug that in, I get 4 minus 2, that's 2. That's equal to 0 times a plus b. So there's our b value. Now I need to let x equal something else. I can't make this go away, so just pick a number. Let's pick 0. Plug in a 0, I get negative 2 is equal to a negative a plus 2, because b is equal to 2. So if I subtract 2 over here, I get a negative 4 equals a negative a. Swap sides, you get a equals 4. Now I know my two fractions. So I've got 1/3 times the integral of, a is 4, so I'll put that here, 4 over x minus 1 dx. And then my b value is 2, so plus, I got that 1/3 has to get distributed to each of these fractions. So I got 1/3 here, and then I've got 2 over x minus 1 squared dx. So if I move that 4 to the outside here, I've got 4/3 integral of 1 over x minus 1 dx. That's a u prime over u. So I got that one taken care of. This one I'm going to move that 2 out, so I've got 2/3 the integral, and then I'm going to do x minus 1 to the negative 2 dx. So right here I already know I've got 4/3 natural log absolute value of x minus 1. Here I didn't have a u prime over u. I've got something inside parentheses raised to an exponent, so I'm going to have to do a quick substitution. So I'm going to let u equal x minus 1, therefore du equals 1, and I just took the derivative of x. So that's a straight across swap. This will be u to the negative 2 du. Add 1 to the exponent, I get u to the negative 1. Divide by the new exponent, plus c. And so my final answer here is going to be this: 4/3 natural log absolute value of x minus 1. Positive divided by a negative, that's negative. This u is going to drop down below the fraction bar, so I've got 2 over 3u. And I'll just go ahead and plug that x minus 1 back in for u, and then plus c. All right, we got one more. So I'll just let you guys know ahead of time that the way that Central words this question, it's really kind of weird. It's like, does the area converge? And if it does converge, to what area does it converge if it converges? You know, something really weird like that. When you see that, you can just think, does the area converge? Make it easy on yourself, okay? So, integral from 1 to infinity of 1 over the 4th root of x dx. Does that area converge? All right, so what I did is I just graphed, and you want to start by graphing this, okay? We need to see what this looks like. I'm doing 1 divided by x raised to the 1/4 for this. And I put my 1/4 in parentheses. You could do x raised to the 0.25, because that's the same as 1/4. And I'll go zoom option 4. I just want to see what this graph looks like. Does look like it's getting close to the x-axis. Kind of looks like an asymptote. I might change my window a little bit. I'm going to go from 0 to 20 on the x-axis and from 0 to 2 on the y-axis. So it is dropping below 1. It's not dropping down very fast. That's kind of making me think, geez, does it converge? If I change my window and say, let's go all the way out to 100, because remember, I'm going from 1 to infinity. I'm just trying to get a picture of what this looks like. Yeah, it's still going down, just not very fast. So if I think back to graphing, anytime the degree of the numerator is less than the denominator, then yes, the x-axis is an asymptote. But I'm going to have to work my way through this to find out. All right, so I'm going to rewrite this integral as the integral from 1 to infinity of x to the negative 1/4 dx. If I add 1 to the exponent, I get x to the 3/4 divided by 3/4, which means I'll multiply by 4/3. And then I'll evaluate that from 1 to infinity. So if I plug in an infinity raised to the 3/4, well, really infinity raised to anything as long as it's a positive exponent is equal to infinity over 3 minus what I get when I plug in a 1, and that would just be 4/3. Well, infinity minus 4/3, 4/3 is nothing. And so that equals infinity. So I would say that the area does not converge. We're going to have an infinite amount of area underneath this curve. So we don't want to think that every single problem we do does converge. You know, we need to make sure and check the whole thing, you know, take a look at the graph. If it looks like the x-axis is an asymptote, well then I need to continue on with the integral. It's a possibility. But in this case, it did not. All right, here's what we have for an assignment. So I believe we're now on number C20. We're going to work on page 589. And we're going to do 3, 13, 17, 25, 33, and 85. So I got one of each problem, each type of problem that we worked on, but you guys could certainly do more, right? I mean, if you're working through this and let's say on trig substitution you kind of struggle and you want to pick another one to do, that's fine. You can do that. Pick an odd one, so you can check the answer in the back of the book. There's no rule that says you only have to do the ones that Judson assigns. I mean, we're getting ready for a test, college test, and so we want to be as prepared as we can. All right? All right, hey, one more thing. This week I'm supposed to have something for you guys Tuesday, Wednesday, Thursday. We just covered Tuesday stuff. Wednesday, my wife is having her last surgery that she needs to have. And we just found out we have to be in there at 5:15 in the morning. So I have a feeling that Wednesday is going to be tough for me to prepare anything. I will have stuff. I will have stuff for you to do on Wednesday because I'll get that done on Tuesday. But I may not have anything on Thursday for you. I do have a worksheet that has some problems, some review questions, a lot of different things on it. I may give that to you guys for Thursday, but I will not have a video for you. So just kind of check the Sway page and the place where I normally put videos. I'll probably just put a link to a review worksheet for Thursday. All right? All right, you guys have a good day. Stay safe.